Right. Good morning and good afternoon or good evening, wherever you're watching this lesson. Uh, I hope you have had enough time and a good time for that matter. I have been teaching on measures of central tendency to a class of craft certificate in building technology, and one of our introductory topic was on measures of central tendency, and we have looked at some of the ways in which we can calculate the arithmetic mean, and we looked at the direct method, and we looked also at the assumed mean method. And so today we would be looking at the computation of the mod. So let's go into the lesson and see how it goes. Now, as you realize, today's lesson is on these measures of central tendency, and allow me to look at the mod. Now, what is mod? What is mod? Now, in a data set, we say that mod is a value that has the highest frequency in a series. So if you're looking at some data sets and you're looking at specific values that have the highest frequency in that series, then that would constitute mod. Now, we may have various forms of data sets that have a single value that has the highest occurring number of value in that series. In this case, we will talk of a unimodal distribution. Unimodal distribution. That is whenever you have got a data set and there is only one value that has the highest number of frequency, then it's unimodal. Sometimes a data set may have two values that have the highest frequency in that series. In this case, we will call it a bimodal. So we call it a bimodal distribution, like that. And if the data set has more than two values that have the highest frequency, then we are saying that this will be called a multimodal distribution. A multimodal distribution. This is distribution, this is distribution, this is distribution. Now, in our case here, we want to just go direct to how we can compute the mod, and we say that the mod is given by the lower class boundary plus the frequency of the model class minus the frequency of the class preceding or coming before the model class, divided by 2 frequency of the model class minus frequency of the preceding the model class minus frequency proceeding or following the model class times the class interval. So we are saying this L stands for the lower class boundary. So let me call it lower. This is R class boundary This L stands for the lower class boundary. Then FM will stand for the frequency of the model class. So just write frequency of model class. Then F1 will stand for the frequency preceding or coming before. Preceding. Preceding the model class. And then of course F2 will be frequency. This is frequency proceeding. This is now proceeding. Proceeding what? The model class. Please, I've written my model in short. And then of course we have said that CI stands for the class interval of the model class. This is the class interval. Now what we are simply saying is that's how we compute. This is how we compute. As you can see, its mod is the lower class boundary plus a fraction of frequency of the model class minus frequency preceding the model class divided by 2 times frequency of the model class minus frequency of the upper preceding the model class minus frequency proceeding the model class times the class interval. Now let's just look at an example so that we see whether we can compute this, because it is important we relate this with the information. So let me assume that I have a class. These are marks of students, and let me call this a number of students. In short, these are students. So I have got 0 to 5, I have got 5 to 10, I have got 10 to 15, and lastly I've got 15 to 20. Let me just add, please, 20 to 25. Those were marks of students, and that let me also further assume that these students, there were 5 students here, there were 9 students here, this is 9. Let me assume also that there were 12 students here, and then here there were 8 students, and then here there were let me call them 4. Now as you can see from this illustration, what we are simply asking ourselves is, what's the mod? So calculate the model mark. So the question is, find the model mark. That is the question. Find the model mark. So what you need to understand is that you need to know that there is what we call a model class. So a model class is a class whose frequency is the highest. So from this data set, you can see this is frequency 5, 9, 12, 8, and 4. So it tells you that this class here, this class of 10 to 15 is the model class. Why? Because the frequency is 12, and 12 is the highest value among these frequencies that we have been given. So it means that 10 to 12 is called 10 to 12 is a class and we are calling this the model class. That's the model class. We are also saying that this 12 is the frequency of the model class, so this will be called FM, the frequency of the model class. Now the frequency preceding, coming before this, is 9, so, and this will be called F1. Why F1? Because it is coming before the frequency of the model class. Then we said F2 is the frequency proceeding or after the model class, so this will be our F2. See, now what's the class interval? The class interval is simply between the difference between the upper class boundary and the lower class boundary. So from this data set you can see the class interval is basically between 15 minus 10. So our class interval here will be 5, the difference between the upper class limit and the lower class limit, or the upper class boundary and the lower class boundary. Now it means that therefore we can substitute, but remember this median model class, as it were, has a lower class boundary. So this is what is your lower class boundary. So 10 is the lower class boundary. 15 minus 10, which is 5, is the class interval. FM is 12, F1 is 9, and F2 is 8. So you simply come and substitute in your equation. So we say that that mod is the same as lower class boundary plus FM minus F1 divided by 2 FM minus F1 minus F2 times the class interval. And we say that the class here is 10. Remember, just remember this, the lower class boundary here is 10, the frequency is 5, FM is 12, F1 is 9, F2 is 8. So you simply come in and substitute. So we are saying therefore this will be the same as, this is the same as 10 plus frequency of the model class, we said it is 12, minus 9 divided by 2 times FM. What is FM? It's 12. So for purposes of this I will put that, minus F1, we said it is 9 minus 8 times, what is the class interval? We have said the class interval is 5. So we can just go back to the figures again and reconfirm that our F1 is 9, our F2 is 8, our FM, which frequency of the model class, is 12. So we can go ahead and substitute. Now from this we know that this will be the same as 10 plus 3 over 24 minus 9 minus 8 times 5. Now so we can you know, calculate this and get the values here. So basically you're talking of you know, you're talking of 10 plus 3 over 24 minus 17 is 7, so over 7 times 5. This is 10 plus 15 over 7. Now you can get your calculator and compute that. Let me check for my calculator here. So what is 15 over 7? 15 over 7 is the same as 2.14. So this is the same as, let me just 10 plus 2.14, and this will be the same as 12.14. See, that becomes your answer. Now, I have always insisted that whenever you calculate your answer, ask yourself whether it is within this given range. See, if we come to our example here, then this was our original data set, 0 to 5 up to 20 to 25. Now we are simply saying that your average must be within the specified range, and so you're saying here that our arithmetic mean ranges, or our model value is in this model class. Our model value is in this model class, and we have found it to be 12.14. I hope you enjoyed the lesson, and tune to our next lesson. And you know, with more practice you can always get these things right. And thank you so much for watching, and kindly subscribe to this channel for similar and more academic related solutions. Thank you.